So in Chapter 9, we open a door to a new branch of mathematics. Usually they call it probability. We're not actually going to get to the probability part. We're only doing 3 sections. We're going to focus on sequences, but it kind of opens the door to another branch of math. And I loved my probability class, so just anyway. So we're going to start out pretty simple with what a sequence is. So pretend a video game. They invent a video game and they say, okay, they discover that on the first day, day 1, they get 2 hits. And then on the second day, it doubles and they get 4 hits. And then on the third day, that doubles and they get 8 hits. And so we have this pattern. So a lot of times that's what we do in math. We look for these patterns. But this represents a sequence. So I'm going to write the sequence here, the hits, right? Okay, so the way to write a sequence is 2, 4, 8, 16, 32. And then we put these 3 dots. Usually we put a comma and then the 3 dots. Those 3 dots are called an ellipsis. And it says this pattern continues this way, okay? So it keeps going. We don't have an end on it, but the 3 dots indicate that it keeps going. Now, sometimes they will write this as a set, and they'll put it in set notation in the squiggly brackets. Sometimes they don't. Sometimes they'll just write the sequence without the squiggly brackets. Okay. So when we're talking about a sequence, we have this it's called the first term. So each, entry is a term. This would be the second term. And then this would be the third term. And so on and so forth, right? Okay. The way we indicate what term we want to talk about, we usually use A to represent, whatever we have. So we say A sub 1, comma, A sub 2, comma, A sub 3. And then we're saying, okay, that pattern continues. And that represents a sequence. Let's see. Oh, if we had a second sequence, we would just say B sub 1, B sub 2. I mean, probably that's the way they would do that. Okay. You might have a reason to choose a different variable, but for our purposes, we're going to be using A a lot. Okay, so that's kind of the notation there. We're talking about terms. They're separated by commas. Okay, so yeah, I want to see if, okay, yeah. Now you could graph this, okay? So let's pretend we have a graph. Notice that the terms are going to be the counting numbers, right? We're counting 1, 2, 3. Sometimes they will have a sub 0, but we won't really get into that. Okay, so say, you're going to have a first term, a second term, a third term, so on and so forth. So when we graph it, our x-axis is going to represent, I guess you could call it, well, anyway, I don't want to call it the x-axis. I would call it the n-axis, but we haven't talked about that yet. But we're going 1, 2, 3, 4, okay? And they give us 5 points, so I'll go 5. But then your output are the number of hits, right? Okay, so that's going up to like 32. So maybe I want to count by 5, 10, 15, 20, 25, 30, 35, something like that. So 10. You'd have to indicate this when you're graphing. But in this case, the outputs are positive. They aren't always, but this time they are. Okay, so on day 1, we have 2 hits. So maybe that's right there. Let me put it in orange, try to make it a little bit easier for you to see. On day 2, we had 4 hits. So then that was like maybe there. On day 3, we had 8 hits. So it's going up a little higher. Day 4, we have 16 hits. And on day 5, we had 32 hits, so way up here. So we see that trend that it's doubling every time, and it's going up kind of quickly. Notice that I almost drew a curve, but I don't draw a curve because there's no function here. This isn't a function. Well, no, it is a function, but I mean, there aren't points in between. There's nothing in between here. There's no, see, we're going 1, 2, 3. There's no 2.5 or pi or something like that. We're just talking about these counting numbers, okay? So anyway, that green piece doesn't exist. So you don't connect the dots, I guess I could say here. Now, what we've shown you up here, and actually what was shown, what was shown here and shown over here, we had the ellipsis, and that indicates that this is an infinite sequence, that it's going on and on and on. Goes on forever. Okay, so not all sequences go on forever, but the ones that do are called an infinite sequence. Okay, we can have a finite sequence. So a finite sequence, that's going to stop. So we could have had our sequence be like 2, 4, 8, 6, okay, let's just say 2, 4, 8, and then put the dots and say we're going to stop at 32. Okay, so here the ellipsis means, okay, it's continuing in that pattern up until 32, but this is stopping. We're stopping here, okay? So, you know, the only number I left out was 16, but sometimes they leave out like a bunch of numbers. They'll have the first couple numbers to show the pattern. You need that. You need to be able to establish the pattern, and then they'll have the last number that they want to stop at. Okay, and this is called a finite sequence, meaning it has a finite number of data points, I guess. Okay, let's see. I feel like I'm leaving something out. We talked about the terms. Okay. Oh, the pattern. So let's look at the pattern here. This was 2, right? And it was the first day, which is 2 to the first power, right? This one, the output was 4, which is 2 squared. This one was 8, which is 2 cubed. So do you see a pattern here? And then we could say this last one was 2 to the 5th. You could put in 2 to the 4th as well. And that's how you could write that pattern, right? Now, if we wanted to make it an infinite sequence, so we wanted to continue on, the last term we represent as 2 to the nth, okay? Well, that's a finite sequence still because we're stopping at n. But this would be called the nth term, okay? So this was the first term, first, second, third, fifth term, and then this would be called the nth term, okay? Now, just because you have an nth term doesn't mean it's finite. You could have the ellipsis, another ellipsis to say, okay, this continues on and it's an infinite sequence. Okay, the way we would write this, we want to be able to generate the term. So that's a word that I use, I've seen that before, but we want something that says, how did I get the 6th term? Well, look at your pattern here. You've got 2 to the first, 2 to the second, 2 to the third. You want to relate that to your n. This was when n was 1, this was when n was 2, this was when n was 3. N indicates which term you're on, okay? So n tells you which term. So if we want to generate any of the terms, it's going to be this right here, 2 to the nth. So if I wanted to know the 10th term, I don't have to figure out the first 9. I could say a sub n equals 2 to the n. This is called an explicit formula. So it's a formula that will tell you, or it's a generator, it generates the term. So I can say a sub n equals 2 to the nth. So let's say I wanted to find the 10th term. Then I'm talking about a sub 10, n is 10, and it would be 2 to the nth. Oh, sorry, 2 to the 10th. I should have picked a different number. 2 to the 10th. Now, I don't want to figure that out. I just want a calculator to do it for me. But I can do that. Grab my calculator. 2 to the power of 10. Oops, turn my calculator on. 2 to the power of 10. And it's 1024. Okay? And you could figure out the other 9 terms ahead of it to determine the sequence, but you wouldn't necessarily have to. Okay. So I think I know this was a long video, but it was the introduction. We'll show you some more examples in the next videos.